Assalamu alaikum kids, this is Ayaz again, and I'm going to teach you math for class 7, and this is week 2, and week 2 of course, week 2 lecture 3, and the topic, we are still continuing with the same topic, other forms of direct proportion, and you can find that topic on your book 2, page 12. And this is again the same recall back to just remind you the basic concepts of the topic which you're supposed to know, which you have already learned in your first week. Direct proportion in words, what you know about this direct proportion. One thing increases, the other one also increase, one decreases, the other one also decrease, and all these increase and decreases must be in a proportion, or mathematically you can write it down, the two equal rates or the two equal ratios is the same thing. And when two quantities, two variables are directly proportional, then graphically it will always give you a straight line which passes through the origin. So that's a kind of a little recap. Let's come to the today's topic, today's questions, and I'm solving to one of the question now. This is question 2 of your exercise 1b on page 18 of your book 2. And this question says that there are two variables, in fact z square and w. So they are saying in the question that z square is directly proportional to w, and they gave us one complete pair z and w. Of course, what was the purpose? What is the purpose for this one? To find the value of k, constant of proportionality. And then again there are four parts over here. First one, we need to find the equation connecting y and z. Second part is find the value of z when w is 18. Third one is now we find the value of w when z is 5, and the last one is to draw the graph between z square and w. And here's the solution now. The first part, as the relationships is in front of you, z square is equal to kw. We introduce the k here, k of k, constant of proportionality. So we use the complete pair y8 and z to 4. I just replace this here. So z is 4 power 2, k into w, which is 8. So 4 power 2 is 16. Now of course not 8. Remember, 4 into 4 is 16. So 8k, and 8 is going to be going to divide on the other side, and it's going to be 16 over 8, and k is 2, and we got the complete relationship now. Z square is equal to 2w. That is the first part, relationship connecting z square and w. And here's the second and third one. In the second part, w is given 18, and we have to find the value of z. So I just replace this w18 in that relationship. So we got 36, and taking the square root of both sides because we need the z, not the z square. So taking square root on both sides, so z is going to be equal to 6 now, plus minus 6, remember. So when you take a square root, it always comes out to be two values, two possible values, plus and minus. Third one, when z is 5, so I replace this now z5. So 5 power z square means 5 power 2, 2 into w, and w is equal to 2 is multiplied on the side will divide 25, because 5 power 2 is 25. So w is equal to 12.5. And the fourth part is basically that we have to draw the graph. So remember again the same logic that the z square and w are connected through direct proportion relationship. So it's we know it's going to give us a straight line, and not only a straight line, that straight line must pass through the origin. So definitely one point, the origin 0 0 is going to be there. So we jump on that point. So w is 0, so I replace this. Definitely I will get z square is equal to 0. So one point is 0 0, the other one I took the w is equal to 2. In fact, you can take any point, guys. So I took w is equal to 2, placing the 2 in the place of w, to z square is equal to 4. The other point is 2, 4. So I drew w on the x-axis and z square on the y-axis. You could see on the screen. So I plotted the one point, of course, the intersection of these two axes is the region which is 0, 0 over there, and one point you will see on x-axis is 2, other one on y-axis is 4. So this coordinate is 2, 4 in red color over there. I just circled that point also. So I joined the 0, 0 and 2, 4, and I got a straight line passing through the region. So that is the graphical representation of this relationship, z square is equal to 2w. And I'm planning in this week to solve another question for you, which is question number 6 on page 18. So it looks like a little bit scary, but it's not that much. So here the two quantities which are directly proportional are q and p minus 1 whole square. And the same as usual, q and p, one complete pair is given to find the value of k, the constant proportionality. And then of course there are just two parts over there, value of p when q is 80 and value of p and q is 80. This is kind of got duplicated here, this typo here. Now guys, let's start it. So as the word says, q is directly proportional to p minus 1 whole square. So mathematically we could write it down. Q is directly, see, this is sign of proportionality, and constant of proportionality, this is a sign of proportionality. So to remove the sign of proportionality, to introduce the sign of equality, we have to introduce a constant of proportionality, which is k. The second step, you could see q is equal to k into p minus 1 whole square. So I'm using that pair now, q20 p3. So replacing q20 p3, you could see, and 3 minus 1 is 2, 2 square is 4, and then 4, bring it that 4 on the other side, it will divide 20, and k is equal to 5, and we got the now complete relationship, q is equal to 5 into p minus 1. From where this 5 comes? No? Yes, 5 is the value of k. So this is the first part. Now then it says we need to find the value of p when q is 80. So now I replace the q80 in the above relationship, and you can see 5 comes down, and then now taking square root of both sides because we need p here. So taking square root of both sides, 16 square root what is 4 plus minus 4 on the right side, square root got cancelled with the square, and we got p minus 1. So there are two basically equations over here. P minus 1 is equal to 4 and p minus 1 is equal to minus 4. So just solving these two on the parallel way. So p is equal to minus 1 goes to the other side, but plus 1 got 5, and on the next one, on the other side over here, you could see minus 1 goes aside plus 1, and we got p is equal to minus 3. So in this relationship we got the two values of p. And finally here is your third assignment, which is question number 1 and 3 of exercise 1b of your book 2. And these two questions are quite similar to what we have done here. I know you're pretty good enough, and you can solve these two questions also. And definitely I'm going to wait for your feedbacks, your answers, and it will make me happy if I got the correct ones. So try your best, and again, goodbye. That's it for today. Thank you.